So things got out of hand. I've cut some uprights and some cross pieces, and this is one of the floor pieces, the base sections. So all the way, that's the tapping size, and then I will drill through most of it, leaving 15-20mm at the bottom for clearance on M12. So I've already got threads down a little bit of it. Put all 4 plugs in, stitch them at the bottom, and then run a bead around them at the top. That will make them really secure. And then I'll roll it all together, and there'll be a stand for the mini mill. So the riser plate, oh, and that's the top plate for it. I haven't got anything wide enough. It's 10mm plate. It's already stitched down the other side. I ran out of wire, so I've got some more wire. Although I've got some 4mm welding rods now, so I might weld it with welding rods now, because I can do that with just one blast all the way down with a welding rod now, and that will be sufficient. So I'm going to be running flood coolant on the mini mill eventually. The reason why I'm using such a thick plate here is so I can drill and tap and put the drains in and everything, and weld some angles on it to make it into like a coolant catch funnel tank mill holding section thing, and it's more rigid. This is just thin wall tubing. I think it's 3mm. Yeah, so that'll be 1/8 inch, and it's 40×80, I think. 40×80. No, 50×100, which is 2" by 4" approximately. Anyhow, that's that set up. Let's go and have a look at the plasma cutting. So I got my little compressor out, and I've got this thing here, and that is a CT520D. It does TIG, arc and plasma. I've got it set to 32 amps. It's a bit overkill, but it slices through nicely. There's my pile of bricks. And I had started doing it with the hacksaw, as you can see. But then I thought that's not going very well, so I put some pilot holes in. And then I've just marked out. And for that side there, I've just gone 6 centimetres and lined up with my hole. And now I'm going to line up on this one here, on the edge of the hole, and make it parallel and do a cut down there, and then those triangles fall out. So I thought you might appreciate watching the cut from the little CT520D. This is at 32 amps, the compressor at 80 psi. When the compressor cuts back in again, and the whooshing noise in the background is the wind turbine. See that? So I can't see the camera screen, and that's what it looks like. It's got lots of hangers on the back, but it cuts it quite nicely. inside the joint there. So I'll go ahead and weld that up now. That looks a lot more pretty. So we are a few hours later, and I have some sort of stand coming along. I'll put this at the top just because there's no plan. It looks like that. It's tapered at the ends. There you go. That's what that end looks like. There's the feet. That's that. Now I've got to weld that top piece up. Oh, you beauty. There's some of my welds. I don't know if you can see anything there. Let's zoom in. There's that. That's 140 normally aspirated MIG. Otherwise it's not a turbo MIG. It's normally aspirated. There we go. Now I did a bit on the what do we do? Did a bit on the garage. The render's coming off, so I just redid that. Ready for the door frame, which is going to go in here. Door frame is going in here this week, or on my holiday this week, these 2 weeks. So I'm going to paint that at some point. I might drag it out and paint it now. Underseal it. The sooner the better, I think. Get it out, get it undersealed. So these are the plugs for the levelling feet. These are the slugs for mounting the coolant tray / mounting surface thing to the frame itself. I've got 3 foot, so I've got 4 tabs which are going to weld onto the top beam, and then these will be M10 to hold that platen to the top of the doofler flop. And I was just thinking to myself that I want to run coolant, so I might as well cut another piece of 20mm off and weld it into the top platen jobby thingy plate. That's where we're at. So the mill stand here, mill stand, I am continuing on with it. I have been today after I did the rendering, and obviously that is to get the mill on. Instead of putting it on the bench, it's going to go on a stand. This bench is coming out, dismantled, going. It is rubbish, but it's got to go anyway to do the floor hardening. So this is nearly done. These have been hammered in, and they are M12 for the first 15mm, and then they become clearance. Then here we've got some hinges, and I'll put some drawers in it. So I've got some of these ball bearing hinges, and I had some HML plate, so I cut that in half with a plasma cutter and just angle grinded the end of it, so you can still see some plasma cutting bits in it. It's fine, just got the rough edges off of it mainly. Left the mill scale finish on it, and driven it out M5, then M4, M4, M4 on all of them. There's 2 length hinges. There's a 500 hinge here, and then there's a 450 hinge here, slider, draw slider, torque draw sliders. Okay, so that's them. They are ready to be welded on now, so I'm just going to weld those bits of 6mm, 8mm plate, whatever they are. I'm going to weld them on to the uprights to support the drawers, the drawer runners. And if they need more support, then I'll put more support on, but I think they'll be fine as they are, because the drawer runners are pretty stout as they are. then they're going to be bolted to a drawer, which is going to be stout, and then they're going to be held on by a piece of 6mm steel, which is pretty stout, so the whole thing together is going to be great. If you put a flimsy drawer in, it probably collapse, but with a good solid 2 or 3mm steel drawer in each one, that'll do. Anyway, here is the plate. It is concaved or convex, whichever way you look at it. And I was straightening it, as you can see by the hammer marks. I don't know if you can see the hammer marks there. Let's see if we can zoom in on some hammer marks. Yeah, you can see the pounding marks. I drove over it on with my works van, which is the heaviest thing I've got, with a strip of wood on this side and a strip of wood on that side. It didn't even flex. Then I pounded 7 bells of crap out of it, spun the plate around 180 degrees and did the same again, and I got it down to a certain amount, and I thought to myself, hold on a second, it's convexed. Instead of making it flat, leave it a little bit. It's about 3mm from centre to end on each side. I thought, leave it like that, that'll be okay. And instead of welding it straight to the frame at the top there, what I've decided is to use these, and I'm going to weld them on there at some point, up and down there. Then on the base I'm going to weld these on, and then drill them and tap them. So I'll square them up as best as possible on the underside. This is the underside, by the way. Yeah. And put them into position. The position being that position there, 160, so 80mm either side of the centre, and 300 on centres, 340 on the outside edges. So I'll line them up, weld all those on, then I'll flip the whole plate over, and I'll do the same thing with these rectangular blocks, and I'll stick them on 225 outsides, 185 centres width, and then 295 to the holes, oh my word, to the holes, and 365 to the outside edges, so 225s and 365s. Oh, and of course I'm going to definitely TIG these in as well, so we'll definitely get some TIG usage tomorrow. And the cover plates here, when I've finished welding these, I'm going to weld these on the inside, down the bottom, and then round the outside at the top. Yeah, that was the plan, but that might change. Right, here is the Laptronics with the tool grinder setup on it, and I am going to do the tungsten for the TIG welder on it. That looks like just in the book. You know when they show you in the book how to do it? That, let me see if I can get a close up on that for you. I can't see anything because the sun's everywhere. There we go. Must be a good picture, that must be. But that is beautiful. So I took around about 5 minutes setting that up by eye. I thought that's about the right kind of angle. It looks about the right kind of angle. It looks beautiful. And the surface finish is beautiful. So hopefully the plasma will come off that absolutely how it should do. So here's the little TIG. I'm not sure how to set it up properly, but I've got it at 101 amps. It's set up in TIG. I've got the on-off thing off. I think that is a build up and a build off. I'm not sure, never done it before. I ain't got the instructions for it, I'm not using it today. Got some argon gas and the sharpened tungsten, which I've just done. And it's live, the whole thing's live. I've just used it to see if it actually works, because the thing was This is a new lead I've got, it's 170 amps, constant rated I believe, and on this machine the TIG torch is supposed to be connected here. This is where the gas is, and the live, or the negative, where the torch is connected, is in where the arc welder would normally go. So I was hoping they were bridged, and they are bridged together, so that's good. So now I can show you it welding. Now for a start, I'm just on a tack, and that is a tack. As you get close up on it, and that is a tack. So I will show you what it. Or there's a filler piece of metal in there, by the way, if you were wondering what the thing is. I'm just tacking that filler in. So I'm just going to tack all this together, and then I'll show you some tacks for a start, and then I'll show you the finished product after I've tigged that together. Now clearly you're not going to be able to see a lot once the welder gets going, because the contrast will just go out of the ballpark, but you'll be able to listen to it welding and make you wonder upon whether it's welding properly or not. Here we go. Everything seems to be going honky-dory. Looking pretty beautiful, because clearly the TIG welding is a lot brighter than MIG welding. Anyway, let's detach you from the thing. Did you get any of that? Probably. Let's detach you from the camera mount. So that's just a little tack underneath. I don't know how good you can see that, it's a bit rubbish. And now on the other side we have another one, which is even more rubbish. You can see that one really clear, that one's really rubbish. I need to grind this, definitely need to grind it. The TIG can't break through that scale like the MIG does, the MIG just goes straight through that. So touching that, head on, let's start to weigh you around a little bit, let's get a bit further out, stop getting seasick. I'm just turning it over. Alright. And then I used the filler metal, that wedge of steel in between it, as filler rod basically. On this side I touched it a few times, as you can see. And on this side, again I touched it a few times. And that's my first time TIG welding with argon. Okay, those of you with a keen eye will see the mistake. it's back to front. Oh well. Anyway, for the welder I have bought this ESAB. I don't know if you can see this. I'll just turn the scope around, I'll be able to see if you can see it. There we go, yes. So I bought this ESAB, high amperage I think it is, 300 amp maximum electrode holder, or stinger, whatever you call it, and it's very nice. And the earth clamp you can see here is a 500 amp clamp and a 200 amp, I can't remember what it is, 16mm squared cable, so it can run 200 amps. So I'm just going to cross the camera for a second to get the helmet. The helmet is auto darkening and it's got a grind function as well, and all the adjustments are inside, and it's got loads of stickers on it because I'll put them on it. Anyway, I'm going to run this 4mm rod. It's a 6013 to weld the stub axles into the chassis. And if there's anything engineering wise, get it out of the way. If there's any sparks, anything like a parallel, it's just going to melt it. So I'm just going to move parallels up. And anything else I can see around, it's pretty safe. So let's turn it on. And this is 175 amps. I just got to do that little circle. I don't know how much of this you're going to have to see. You're going to see a lot of sparks, I can assure you. Right, here we go. Is this? Yeah. Should be. Everything's good. Everything is good. Let's see. That's a 6013. I'll bring you in and show you that. What that looks like. Let's just disengage the camera. There we go. Zoom back out a bit. Right, so that's used half the rod. I bought 2 rods out just in case. I've got 2 of these to do. I think I should be alright with just 1 rod. Here is the weld, and I'm just gonna lift off the slag, and there we go. Not the prettiest of welds. I waved a little bit, didn't I? I got a pit at the end. Oh well. It's definitely in there now. There's no doubt about that. It is definitely in there now. Okay. So that is the little 520 CT520D down there. You've seen it plasma cut. You've seen it TIG. I'll show you the outcome of the TIG. So here is some better TIG welding. I'm not very good at any of this. I'm just get by. As Double Boost would say, I'm just a mechanic that pisses about. But that's without filler rod. That's without filler rod. That bottom bit I think is without filler rod, and the top bit's with filler rod. And this side, that's with filler rod. Yeah. And then here's some more TIG. You've got that bit there, that's with filler rod, it's quite nice. Talking about this bit here, and the same bit left-handed, not very good, but still welded on the wrong way round. There's nowhere wheel can go here now and be, because it just doesn't work. So I've got to put this back in the milling machine, cut that weld out there. Can you see that weld? Probably. I've got to cut that weld out there from inside there. Drag those two rods out. Modify this end and that end so it can accept the rod, because that was just a butt joint. And then weld these in the opposite way. Because I'm not taking them back off again now, because that'll be some work getting them off.